So let's move on to our third constant acceleration example. So here's our example. A ball is thrown vertically upwards. So again, this vertical idea. So we're going to be using acceleration due to gravity here. A ball is thrown vertically upwards with velocity 14.7 metres per second from a platform 19.6 metres above the ground. And then we're asked to find the time taken for the ball to reach the ground and the speed of the ball on hitting the ground. Okay, so let's draw a diagram of this because it's not just from ground level now. We've got this platform above the ground. So it doesn't need to be at all to scale or anything like that. But there's my ground. So this is 19.6 metres above the ground. Okay, I'm throwing this ball vertically. So it's going to do this and then come back down. So it's going to be going upwards, reach its maximum height there, velocity of 0, and then start coming back down, speeding up until it hits the ground down here. So this is where we've ended up. Okay. And it tells us it's sent upwards with an initial velocity of 14.7. So that's what's happening there. And we've got this 19.6. Okay. Let's have a look then at part A. So for part A, what's happening? Let's look at Suvat. Okay. Now this point is really important. Displacement I do know here. We've got to be really careful here. I'm going to again take up as positive. So I'm telling the examiner that I'm taking up as positive. And here's my starting level here. So there's my starting level. So that's where my displacement is 0. Now this is where it's really important we get our heads around the difference between distance and displacement. Distance will be I've travelled up this bit, I've travelled down this bit, and then I've travelled down this 19.6. Displacement though is just where are you at the end of your motion relative to your beginning of your motion. So it doesn't matter what's happened in between, a bit like vectors, it doesn't matter how you got there as long as you've got to your end point. So here my displacement is, this is my starting level, this is my end level. I'm taking up as positive, so my displacement is minus 19.6 because I'm 19.6, I've ended up 19.6 metres below my starting point. So it's negative because I'm down here. This is positive. Think about this as the x-axis. Okay, so my y distance here is definitely negative. So 19.6 metres below my starting point. And that's why it's negative, because I've taken up as positive. But it's really important, like I say, that we get our heads around the displacement has got nothing to do with what's happened in between. It's just where have you ended up relative to where you started. So overall, my displacement is 19.6 metres below my starting point. Okay, let's get some other information in here. U, we're told, is 14.7. V, I don't know, because we're asked to find that in the next bit. A is minus 9.8, acceleration due to gravity, downwards, I'm taking up as positive. So there's my bits of information, and I want to know the time taken. So S, U, A and T, so I'm going to use my equation S equals UT plus a half AT squared. So I'm going to get a quadratic here, but that's okay. So let's substitute in. Minus 19.6 is 14.7T plus a half minus 9.8 for acceleration, t squared. If I sort this out, again, I'll let you do that, please. So 14.9 squared minus 14.7 t, 4.9 t squared minus 14.7 t minus 19.6 is going to be equal to 0. Now you can divide by 4.9 here actually, because 4.9 goes into these, and you'll get a simpler quadratic, but you don't have to. You can just use these in your quadratic formula or on your calculator to work out your values of t. So if you did divide by 4.9, it does actually work out to be a bit of a simpler quadratic, but it doesn't matter, we can use these values anyway. And you should end up here with, again, I'll let you do some work in here, with t equals 4 or t equals minus 1. Now t equals minus 1, we can't have a negative time, so that's a bit of a contradiction there. And what that actually is, because this ends up being sort of a quadratic curve, it would have been, what would have happened before the start. If we rolled back time and this thing was down here, it would have been minus 1. But starting here at time is 0, it's taken me 4 seconds to get there. So t is equal to 4 seconds. Okay, so that's that bit of the question. Now the next bit of the question, I'm just going to keep the same piece of paper, I think, and just do that here, so I can keep my diagram. The next bit of the question was the speed on hitting the ground. Now, some people get a bit confused here and go, well, if it's hit the ground, its speed is 0 because it's hit the ground, then it stopped. But that's not what it's talking about. It's talking about as it hits the ground, that instant that it hits the ground. So that instant of smack, it hits the ground at that instant. What is the speed? Not when it's been sitting there for a while, so it's, it's just at rest, but actually at that instant when it smacks the ground, what is the velocity at this point? Okay, so let's do our suvat again. And again, what do we know? We know minus 19.6 for our displacement, 14.7 for our initial velocity. Our final velocity at that point of smacking into the ground, that's what I want to know. A is equal to minus 9.8. I don't know t. Oh, sorry, I do know t. T is 4 actually, so I could use t as 4 here as well. So I could put t as 4 in there and use that. Your free choice then of equations. I'm not going to use this only because I worked this out. What if I've made a mistake? If I don't have to, I won't. But you could check that in one of the other equations as well. So using these four, v squared equals u squared plus 2as, substituting in, you should get v is equal to, v, for you sort that out, substitute in, plus or minus actually the square root, isn't it? So plus or minus 24.5 metres per second, okay? And in this case, it would actually be negative because I'm taking up as positive, so my velocity would be minus 24.5 in the context of this because I'm taking up as positive, so it's hitting downwards. But interestingly, this question asks for speed, not for velocity. So what does that mean? That means the speed, which is the magnitude of the velocity, is just 24.5 metres per second, and it would be in that downward direction. So there's our answer for that question. Okay, let's do another one. So a particle now is projected vertically upwards from ground level with speed 50 metres per second. For how long, so we're looking at time, is it more than 70 metres above the ground? So let's think about this. We're projecting this particle up, so it's doing this. And I'm exaggerating this kind of forward motion, it's just going up and down, but over time this is what's happening. I'm projecting this up. It tells me u is equal to 50 metres per second in this upwards direction. What else do we know? Well, we're also told here, for how long is it more than 70 metres above the ground? So if that's my 70 metres, that's going to be my displacement. So going from here, I'm hoping I'm going to get 2 times. So I should get 2 different times. Once when it passes 70 on the way up, the displacement is 70. Doesn't matter what's happened here. At this point, my displacement is 70 again because that's my difference between my distance at my starting point 0 and where I ended up at that point. So displacement 70 at that point and then at that point as well. Okay. So let's substitute in. I'm taking up as positive. Always tell the examiner that. It's good to write it down to remind yourself as well. So S is going to be 70. That's that. Positive this time. Y value positive. Direction is 70. U is 50. Positive because that's acting upwards initially. V, we don't know. V would be 0 here, but I don't want to know that. So I don't know what the velocity is at this point here. Acceleration, though, I do know because it's all to do with gravity. So again, minus 9.8 because gravity, wherever I am, is always acting downwards. So I'm taking up as positive, minus 9.8. And what do I want to know? I want to know t. So S equals ut plus a half at squared. Again, we're going to get a quadratic here. Half 9.8, 4.9. Numbers aren't as nice this time. So 4.9 t squared minus 50t plus 7t is 0. Bit of quadratic formula. I'm going to leave you to do that. You should get t equals 8.52914, etc. Or t equals 1.6749. So what does this mean? This means, if I call this t1, that's at this time, so 1.67 odd seconds to get there, and then it's carried on upwards, come back down, it's hit 70 metres again at this time, t2. Let's check the question. How long is it more than 70 metres above the ground? So I want to know how long it's in this bit. So it's taken me 1.67 seconds to get here. 8.5, 3 seconds to get here. So the time in between up here must be the difference between those two. So my time required is going to be T2 minus T1. If you put those into your calculator, and again, use the full values, you should get 6.854. So 6.85 seconds to 3SF. Okay. Let's have a look at another question here. So, here we go. A stone slides, excuse me, in a straight horizontal line. And what are we doing here? Stone slides straight horizontal line, passes point A with velocity 14 meters per second and point B 2.5 seconds later. Assuming deceleration, so it's slowing down here, assuming deceleration is uniform, given that AB is 30, find these different things. So let's draw a quick diagram here to see what's going on. So this time it's horizontal, so I'm not going to have gravity involved here. So points A and B tells me that's 30 meters across there. So there's my 30 meters. What else does it tell me? It tells me passes point A. So initially, if I take A as my starting point, U is 14. And by the time it gets here, it's taken me 2.5 seconds to get there. So that's what's happening in my motion. I'm going 30 meters, starting, if I take A as my starting point, my initial velocity 14, ending at B, if I take B as my end point for this particular section of motion, 2.5 seconds later. Let's have a look at what we're asked to find. So I'm just going to move this up slightly. So S, U, V, A, T. I know that S is 30. I know that U is 14. I don't know V. I don't know A. A is what I'm actually asked to find. Deceleration, so I'm expecting this to be negative because this thing's slowing down. T is 2.5. So V I don't know and I don't care about, so let's have a look at that. S equals UT plus a half AT squared. I'll let you do this, substitute these values in. You should end up with your acceleration is minus 1.6 meters per second squared. So that's deceleration. So a deceleration of 1.6 meters per second squared. This thing's velocity is getting less. It's slowing down as it's going along the ground. Okay. Next bit of the question, the velocity at B. So the velocity at B here, again, let's do our suvat. What do I know? I know that S is 30. I know that U is 14. V is what I want this time. I know my acceleration now is minus 1.6. I can use that. I know that the time taken was 2.5. So again, different ways of doing this. I'm going to let you do this. It's a bit of practice. You should end up with, sorry, not T, V equals 10 meters per second, okay? And in this one, that acceleration is the one that I maybe don't need to use, but whatever way you do it, you should get V as 10. Okay, I think what I should have said at the start here as well is that my motion here is going from A to B, it's going in that direction. So in all of this, I'm taking to the right, you know, in the positive X direction as positive. And I probably should have made a note of that at the start of this. Okay, last bit of this question, part C, how long after passing A does the stone come to rest? So we're not talking about B anymore, we're talking about just how long does this thing take to eventually slow down and come to a stop. Okay, so let's have a look. S-U-V-A-T. Well, comes to rest, this, if something's come to rest, then it's stopped and its velocity is 0. So my final velocity, and that's really important again there, if something has come to rest, it's stopped. So its final velocity then is 0 there. It's stopped at that point. What else do we know? I know, you know, all these different things again. I don't know now what S is anymore though, because it's not this distance, it's some other distance that it's taken to come to rest. U though is still my 14. T is what I'm after, so I need to use some other bit of information here. Well, I'm going to have to use now one of these things that I've worked out. So here I know that my acceleration, and it's constant acceleration in this question because that's what it says, assume the deceleration is uniform, so the deceleration doesn't stop, doesn't change at all, sorry. It's always going to be this for the whole of this motion. So acceleration, I can now use minus 1.6. I want to find out what T is. Again, I'm going to let you do a bit of work on that, please, and you should get T is 8.75 seconds. So give that one a go, please.